Hey guys, Miss Miklos here, and in today's lecture, we are going to be talking about trigonometric word problems, and I know that sounds really exciting. And the fun part about today is that it actually is all going to take place at school. Now, obviously, you guys are watching this at home, so I went around school and I found a bunch of different word problems that we see every single day and just walk by and probably don't even think about math. So hopefully this gives you guys a little bit of insight as to where we can see word problems on an everyday basis. So the first thing that I want to just mention is that whenever we are dealing with one of these trig problems, my very first thought should be that somehow when I'm drawing a picture, it should form a triangle. And to kind of save some time, you guys will notice on the note handout, I already have these pictures and these triangles kind of drawn out for us. So, some of you guys may have noticed this ladder that is on the gym and wondered, how tall is that? So, my goal was really to figure that out. And what I found was that the angle of elevation, which is a key term, angle of elevation is formed with the horizontal and the hypotenuse. And I'm going to kind of zoom in here. But this angle, ooh, there we go. Okay, this angle of elevation I found was 25 degrees. And the angle of elevation to the very top was 52 degrees. Some other stuff that I figured out that the distance to the foyer was actually 17.2. And then I found that this entire length, like all the way to the actual gym, which the perspective on this picture makes it a little bit tough, but was 24.5 feet. So I actually did all those measurements. And what makes this problem kind of tough, and I'm going to zoom out again, is that I'm trying to find this distance to the ladder. There we go. Actually, no. We'll stay zoomed in for the moment. Sorry for all the zooming in and zooming out. But I want to find this distance, so I'm going to call that x. That's really what we want to find. The problem is this is not a part of any of the right triangles. So what I notice is that if I take this whole distance and subtract the distance of the foyer, I'm left with that length of the ladder. So I'm going to call this whole distance, let's call that y. And I'm going to call the height of the foyer z. So if I actually want to figure this out, I know that the height of the ladder is going to be the whole gym minus the foyer. Okay, so those are the two lengths that I really need to go ahead and figure out here. So if we're looking at this, if I know this angle of elevation and I know the adjacent side, and we're trying to find the opposite side, so that means that I need to use tangent. So I'm going to say tangent of 25 degrees is z over 17.2. So to get z all by itself, I'm going to multiply by 17.2 and put the tan of 25 into my calculator. I would recommend putting it in like this. Then I don't have to worry about closing the parentheses on the 25 or anything. And it comes out to be like 8.0. Now, I want to note that I'm not actually rounding this yet. I'm just writing it as a rounded value, but I'm keeping like the whole value actually in my calculator. Now, that tells us the height of the foyer. It's telling us that it is 8 feet. So now what I need to do, I need to figure out, well, what is the height then of the actual gym? So I'm going to do tan of 52 equals y over 24.5. And same thing, I'm going to do 24.5 times the tan of 52 degrees. And that is equal to y. And I end up getting 31.4 is equal to y. So our final answer here to find the height, I'm going to do 31.4 minus 8.0. So I end up getting that it is 23 0.4 feet. So the whole point of this particular problem is really for us to understand that sometimes what we're trying to find is not a part of the right triangle, so we need to do a little bit of work to figure it out. In this case, I had to use two different right triangles and subtract those values. Sometimes we'll use two different right triangles and add those values. Okay, but this is a common, what I would say is a tougher problem because we definitely need to examine what are we trying to find and how can we make that part of a triangle. So I want to just answer these two questions. The first one is, what two lengths of the triangle form the angle of elevation? And I'm going to say it's the horizontal and the hypotenuse. Or we could have said that it was the adjacent and the hypotenuse. My other question is, if the angle to the top of the foyer were smaller, would the length of the ladder change? And our answer obviously is yes. It would be longer, because if the angle to the top of the foyer were smaller, that would make the foyer shorter, which in turn would make that ladder a bigger length. Okay, so we can kind of see that everything is relative based on the angle we are talking about. Okay, problem number 2, which in my opinion is the toughest one on here. It says, two students are arguing about the height of the light fixture hanging outside the gym. I know you guys get into arguments like that all the time at school. So these two students are standing at A and B, and it tells us that the angles of elevation from the ground to the light fixture are going to be 51 degrees and 22 degrees. And it tells us to find the height of the light fixture. And what I figured out, and I measured this myself, is that the distance between those two were 32.7 feet. Now what makes this one tough is we can clearly see this is not a right triangle, so that's why I drew this line straight down. And we just need to kind of think, if this is what I want to find, and I'm just going to call that H, if I knew that this was like 5 feet, I know that this would be the total minus 5. So I'm actually going to call this X and call the other piece 32.7 minus X. And what I notice that I have now is actually two different variables. And we've learned when we have two variables, we need to have two different equations. So if I look at this first triangle, I know the opposite and the adjacent. So I'm going to go ahead and say tangent of 51 degrees equals h over x. My other equation here, with 22 degrees, I know the opposite and the adjacent, so I'm going to say tan of 22 degrees equals h over 32.7 minus x. There we go. And if I look, I can see I have two different variables. I'm going to want to use substitution here. So I'm going to go ahead and get h by itself here. So this becomes x times the tan of 51 degrees equals h. So in this equation, wherever I have an h, I'm going to replace it with x times the tan of 51 degrees over 32.7 minus x. So what I'm going to do here, I'm going to multiply. So I get 32.7 minus x times the tan of 22 degrees equals x times the tan of 51 degrees. And I'm going to have to kind of figure out what these values are approximately in my calculator. So I get 32.7 minus x. The tan of 22 degrees is 0.40, and the tan of 51 degrees is approximately 1.2. So I'm going to have to distribute this value, and I get 13.1 minus 0.40x equals 1.2x. When I go ahead and add 0.4 to both sides, I get 13.1 equals 1.6x. So I get 8.2 is x. So what we actually just found here is I found that this distance, wait for it, Number 3 says the Orange County Fire Marshal did his annual inspection of the emergency sprinklers. Sprinklers are needed in the hallway of the school outside the athletic offices. Find the angle that the water makes with the ceiling, which is an angle of depression, in order for the spray of the water to overlap 2 feet. And it tells us that the height of the ceiling is 9 feet. Well, I actually measured and I figured out that this was also 9 feet. So, some things that I just need to know is, first of all, what is an angle of depression? And the whole point of an angle of depression is an angle of depression goes out and down. So, if I'm looking at this triangle right here, this would be our angle of depression. Now, I know this side is 9, but to find this height, okay, I know this is 2 feet, and then these two pieces are evenly split. I know this has to be 3.5 and 3.5, because if I add those all together, it equals the 9 feet that I measured, which makes this side of our triangle, let me make that darker, 9, to be 5.5 feet. As soon as I determine that, to find this angle, I see we have the opposite side and the adjacent side. So I know that I'm going to do the tangent of theta equals 9 over 5.5. So in my calculator, I'm doing tan inverse of 9 over 5.5, and I end up getting that theta is 58.6 degrees. So the whole key here is that I need to realize what an angle of depression actually is. And would the angle of depression change, or how would it change if they were closer together or further apart? And it would become larger or smaller depending on where that actual angle of depression was. On number 4, Mr. Meyer was chasing a parking violator in his speedy Lancer cart. He's not sure if the cart has enough power to handle the steepness of the ramp to make it to where the student is standing. We need to find the angle of elevation for Mr. Meyer's cart from the beginning of the ramp to where the student actually is. So, some things that I determined. Okay, this is what we're trying to find. It might help if I was in my pen. Okay, that theta. I actually measured that the distance was 606 inches, and I figured out that the height of where the student was actually at 35.75 inches. And the key thing when we are measuring is that I need to be in the same type of measurement. So I know most of the time we talk about feet. Here I'm showing us that in inches it doesn't matter as long as these are both, if these are both in inches, then we're good. So in relationship to this angle, I know the opposite and I know the hypotenuse. So I know that that means opposite and hypotenuse, we should be using sine. So I'm going to say sine of theta equals 35.75 over 606. And when I put that into my calculator, I get 3.4 degrees. Okay, which I think we would all admit that that is a pretty small angle of elevation. So my next question is, do you think there are regulations on angles of elevation for ramps? And the answer obviously is yes, because we could see if this gets much bigger, that incline becomes too steep and people would either be falling down or wouldn't be able to make it up that particular ramp. One Wednesday morning, Sally decided to stop at Starbucks on her way to school, causing her to be late to third period. I know none of you guys do that. As she stepped off the bus, she heard the Pledge of Allegiance begin and turned to face the flagpole. Of course, Sally is a great math student, so she was curious what the height of the flagpole was. So she knew her angle of elevation is 71.8, and she's figuring out what that height was. So I'm going to zoom in here. So we know the angle of elevation, we've used that term a lot today, is the angle that is formed with the hypotenuse and the horizontal. By the way, I'm going to admit I'm really proud of all my pictures here, so thanks for appreciating them. And we're trying to find the height of the flagpole here. And I figured out that Sally was actually standing exactly 10 feet away from the flagpole. So if we look at this, okay, H is our opposite, and 10 feet is our adjacent side. So I'm going to do tangent of 71.2 degrees equals H over 10. And if I go ahead and put that into my calculator, and I get 29.4 feet is equal to the height. Our follow-up question here says, suppose the height of the flagpole is 40 feet, find the angle of depression to Sally. And I'm not going to go through the whole question, but I definitely want to show us where the angle of elevation would be. So if I was going through this, we've learned an angle of depression goes out and down. So this angle right here would be our angle of depression. And our final word problem of the day. Because of a very tough workout, Billy did not look forward to walking up the stairs to get to his locker in the school building. We need to find the angle of elevation from the bottom of the staircase to the top to see how strenuous the climb will be. And I actually measured out that this was 40.75 inches, and this was 69.5 inches. So I can see this is the opposite and this is the adjacent. So that means I need to use tangent. So I'm going to say tangent of theta equals 40.75 over 69.5. So in my calculator, I'm doing tan inverse of 40.75 divided by 69.5, and I get that our angle is 30.4 degrees. And it asks, would the angle of elevation be different if we had only used the first step? And the answer is no, so we might feel kind of sad because we did all this work. But the angle of elevation would be the same, so I really could have just measured this first step, either the height or the length, or I could have measured that hypotenuse as well. So some key things for us here is that we need to draw out the picture, label what we know, and then choose our trig function that we're going to use based on that information.